Hi, good morning everyone. I am Shiny, Computer Science Engineering at Imala Research Institute College of Engineering. Now I am going to about talk name of synchronous with asynchronous with execution. Synchronous execution definitions mean synchronous execution is a process where tasks are executed one after another in a fixed sequence. That means process are executed first in the first tasks are completed, then another tasks one executed to another executed fixed sequence, one by at the same time. At the same time no execute the process, but one by one to the fixed sequence, setting the fixed sequence. For example, key idea: a task must complete before the next task starts. That means if you 10 tasks are you have, first you have to first execute the task, then that task completed or executed in enough, then second task is started, but not at the same time execute the 10 tasks. Characteristics for synchronous execution characteristics are blocking operations, sequential workflow, single thread focus, predictable results. Blocking operations means at the same time processing running time, suddenly talks are suddenly processed. If you, for example, 10 tasks are you have processed, suddenly at the time processor 10 tasks is processed, that time block the operations, so error are not working the process, so avoiding these problems. Then sequential workflow, that means if you have first one steps is completed, then another steps, line by line or one by one sequential workflow. This process are executions are allowed. Single thread focus, that means only one thread, that means problems, I need one thread focused as used. Last one, predictable result. How to implement, how to predict exactly, or as if minimal output of results of you gathering. What is execution? Execution is the process of performing instructions or tasks in a computer system. Execution models determine how tasks are scheduled, how resources are utilized, how efficiently programs run, user experience, and responsiveness. What is execution? That means execute process performing or instruction or tasks in a computer. How to work, how to identify, how to know the threads, how to efficient program, how to run the program, how to experience a response. These are the executions of the program. If you give this task or program, and if you then any tasks are used, schedules, any typing, any information you have want, that means how to this program efficiently, how to this program run. These are the reasons, and this is the execution. How synchronization execution was. Main features of the synchronous execution is the systems in which the following bounds for lower and upper bounds and execution time of process can be set. Transmit Second point is transmitted message was received within a known bounded time. Then one is draft rates between local clocks have a known bound. Lower and upper bounds on execution time and transmitted messages are received within a known bounded time. And the third one is drift rates between local clocks have a known bound. Mm. These synchronizations of the important sequence are made. In a synchronous distributed system, there is a notation of global physical time that only synchronization distributed systems have a predictable behavior in term of timing. Only such systems can be used for hard real-time applications. Next point is in a organization's distributed system, it is possible and safe to use in timeouts in order to detect failure of a process or communication link. It is difficult and costly to implement synchronizations or distributed systems. For steps only start task A until wait task A complete. Wait for task A complete, then you will be start with task B. Wait then until task B complete. Continue to task A, C, task B flow. You have to see the diagram task A, task B, task C. These diagrams are easy to understand for everyone. Once again, synchronization easy for execution. First, you got start A. If you have three tasks, first task is completed and they wait the completed task A. Then task 2B start. Then wait until task B completed. Then continue to task C. Then diagram, if you have note the diagram task A and task B. Task A completed, then go to the task B. Then task B completed, then go to the task C. Advantages of synchronization execution. For executions of advantages, easy to understand, simple coding structure, easier debugging, better control over execution order, suitable for small applications, less risk of race conditions, predictable program behavior. Predictable program for behavior. These are the advantages of synchronization. Once again, easy to understand, simple coding structure. You have easy to understanding this synchronization execution. You to use the simple coding structure, not severe coding, but simple coding useless. Easier debugging. You have handle find the debugging. For debugging error, you count the finding the debugging. Then better control over execution order. If you have to control the execution, if you control this execution, then suitable for small applications. Suitable for small application, less risk of race condition, critical program behavior. The disadvantages synchronous execution, long waiting times, resource and underutilization, poor scalability, lower responsiveness, can freeze user interfaces, not suitable for high performance systems. Disadvantages synchronization means long waiting time. Yes, if you have long waiting time, yeah, for example, task A, task B, task T, if you wait 10 first stops, you will be until wait. So, more time of you use this task completed. Resource utilization, then poor scalability. For storage is poor, lower responsiveness, waiting for ending responsiveness is lower. Next topic is asynchronous execution definition. Asynchronous execution allows tasks to start and continue without waiting for other tasks to finish. Do not key idea. Do not wait continue execute the other task. At the time you have possible the task execute to at the time process to the execution. Execution. This time non-blocking operations, concurrent processing, event-driven execution, efficient resources utilization. Asynchronous uses many possibles, many distributed systems or asynchronous. For example, internet. Then no bound on process execution time. Example, nothing can be assumed about speed, load and the reliability of computers. Computers. No bound on message transmission delays. That means nothing can be assumed about speed, load, reliability of interconnections. No bounds on drift rates between local clocks. Next, importance of asynchronous executions means in an asynchronous distributed system there is no global physical time. Reasoning can be only in terms of logical time. Asynchronous distributed systems and unpredictable in terms of timing. No timers can be used. Asynchronous systems can widely and successfully used in practice. In practice, timers are used with asynchronous systems for failure detection. However, additional measures have to applied in order to avoid duplicated messages, duplicating execution of operations, etc. How to work synchronization, asynchronous execution works. Steps: start A, continue with task B, continue with task B, receive result when a task complete. Flow diagram: at the time task A, task B is running together. At the time task B and task A is running together. Advantages of synchronous execution: faster execution, improved responsiveness, better multitasking, efficient central process unit utilization, reduce idle time, handles multiple requests simultaneously, and modern web and mobile apps. Disadvantages of asynchronous executions: complex program design, difficult debugging, requires synchronization mechanism, possibility of race conditions, error handling is more challenging, higher learning curve. Real blind examples: synchronous for ATM transaction processing, traditional file reading, simple calculator operations, sequence data entry systems. Asynchronous means online shopping website, video streaming platforms, chat applications, email notification, cloud computing service. These are the example of synchronous and asynchronous. Programming examples: Synchronous programming, C programs, basic Java programs, sequential scripts, and asynchronous programming, JavaScript promises, asynchronous await functions, Python scenario, Node.js applications, event-driven systems. These are the programming for examples. Applications in modern computing. Before that, you know that synchronous execution and asynchronous execution and differentiation. Synchronous execution means the first task in a program must finish processing before moving on to execute the next task. That time asynchronous executions means a second task can begin executing in parallel without waiting for an earlier task to finish. Then second point, lower and upper bounds on execution time of processes can be set. Then asynchronous executions mean no bound on process execution time. Synchronous execution transmitted messages are received within a known bounded time. Asynchronous execution no bounded message transmission delay. Synchronous execution speed drift rates between local clocks have a known bound. Asynchronous execution speed no bounds on drift rates between local clocks. Then applications in modern computers mean areas using asynchronous ECS where which they are used in this application web servers, mobile applications, artificial intelligence systems, Internet of Things, distributed systems, cloud platforms, online gaming, real-time communication system. These are the application system used to the modern application for asynchronous execution, web servers, mobile application, artificial intelligence systems, Internet of Things, distributed systems, cloud platforms, online gaming, real-time communication systems. Then this synchronous execution process tasks only be one. Asynchronous execution allows tasks to run independently. Synchronous systems are similar but slower. Asynchronous systems are faster and more efficient but more complex. Modern applications increasing really on asynchronous execution for better performance. Thank you.